Very good evening, all my dear students. Welcome back again to your Unacademy NEET English channel. Hey kids, how is everyone? I hope all of you are doing great. So today we are going to start with really fantastic this types of reactions, fantastic, awesome session. Because if I talk about chemistry, these reactions holds a hell lot of weightage. But before I'm going to start, everyone do let me know. Can you hear me? Can you see me? Your HSP Baba, that is Magical Chemistry Guru. So I'm over here. You can see 23 plus years of teaching experience, dual degree if you know very well, that is MTech as well as MSc. So kids, I can see the Josh in the chat section. I want to see some fire. That yes, how's the Josh? I can see Subhasri is there, Chandu is there, Salet, Aaron, everyone, Muhammad Idris is there. So, hey, Vidhajanani is there. So, all my wonderful kids are there, and definitely the last lecture what I have taken, I have already told you that kids, you are selective. You are really the best students who are going to do the best. We don't need crowd. We need selected students, those who can understand the elite things. So you are really those kids, and I can see the fire in the chat section. Now, let me tell you, this is me, you know very well. And if you're new to this channel, subscribe it and like it. And now this is the flow chart, types of reactions. If I talk about type of reactions, just the reactions are written over there. I'm not saying that you should follow these reactions. Now see, let me tell you these reactions in my own way. That suppose you are provided with one bag. This is one bag. And if I say in this bag, 1, 2, 3, 4, 4 mangoes are there. And in this bag, 4 apples are there. And the bag is full. Let me write down some more mangoes. 1, 2, 3, 4. 8 mangoes and 8 apples are there. Now the bag is full. Now if I ask, in this bag, one guava you have to keep. Your doctor has told you just to keep one guava in this. One guava to be added in this box. Doctor has told you to add guava. As already this bag was filled with mangoes, the apples, an apple a day keeps doctor away, you know very well. 4 mangoes, no, 8 mangoes, 8 apples, 1 guava, you are supposed to keep it over there. What you are supposed to do, kids, do let me know. Buddha Surya is saying, sir, I recently subscribed this channel. Can I directly watch this video? Yeah, you can directly watch this video. You will be able to understand, because today it's the starting and I will tell you each and everything in detail, starting from the zero level. Yeah, definitely. Now see, if you want to keep this guava over there, so if you want to put this guava, you have to remove either mango or apple. One thing should be removed so that the place of this apple or mango is taken by guava. This is known as substitution reaction. Substitution means something is added and something is gained on the same atom. That is mostly the carbon atom. Now suppose if I say the mango is not full. This mango is, this bag is not full. Suppose it is partially filled. Now somebody is saying just keep this guava in this bag. Put this guava in this bag. What are you supposed to do? Are you supposed to remove anything? No. Just add guava, because this bag is partially filled, this is known as addition reaction. In addition reaction, the reactant becomes saturated. Now, if I say this bag is suppose overfull, filling is too much, oversaturated. Now just remove some guava, remove some mangoes, remove some apple. This is known as elimination reaction. So kids, how many types of all total reactions are possible? 3 types of reactions are possible: substitution reaction, elimination reaction, addition reaction. These 3 types. One more category is there, kids. Let me tell you that if somebody is saying don't remove apple, don't remove mangoes, just change the arrangement as you have seen in solid state. If you're not going to remove, just place is different. For example, you must have gone to a school. Your teacher is saying, suppose, hey Ramu, you sit over there. Shamu, you come and sit over here. This is known as rearrangement, changing of seats. So 4th type is rearrangement reaction, and that I will tell you in between whatever it's coming. Now, this substitution reaction will be further divided into nucleophilic substitution, electrophilic substitution, free radical substitution reaction. Now, nucleophilic substitution reaction I will tell you in detail. Electrophilic substitution reaction I will let you know in detail, and free radical substitution reaction also we will see to it in detail. Now, this NSR is divided into SN2, SN1, AR means aromatic SN2, aromatic SN1. So today we are going to start with SN2 reaction. SN2 reaction. So here is SN2 reaction, kids. Are you ready? Everyone do let me know that yes, you are ready for it. Kids, tell me that you are ready for this SN2 reaction. Let me know everyone that yes sir, we are ready. Everyone do let me know that yes kids, you are ready. Everyone is ready. This is your SN2 reaction. So kids, let's start this SN2 reaction. No need to cram. Just try to understand. This 2 stands for kids, bimolecular. So 2 means bimolecular. This is bimolecular nucleophilic substitution. Now 2 means this reaction follows second order chemical kinetics. Now kids, what is this? We were about to study organic reactions, but here we are going to deal with chemical kinetics. This is not good thing. Kids, just do let me know in the chat section, do you have basics of chemical kinetics or not? If you know basics of chemical kinetics, then I will ignore second order chemical kinetics. But if you don't know anything about second order chemical kinetics, do let me know. Then I will let you know just the basics. What does this mean? Kids, do let me know in the chat section. Yeah, GLG Shravan, it is from. Oh, Srinath is there, Priyanka is there. Oh my God, number of students are regular students are there. Yes, this is from Hello Alkanes, Hello Arenes. Kids, do let me know that you know. Okay, you don't know. Okay. So see, first of all, we have to understand what is the meaning of this second order kinetics. Let's see the meaning of second order kinetics. Second order, we are going to understand. Let me tell you one thing very clear. In organic reactions, there is one substrate, that is, you can say reactant. reactant. And another one is being, yes, kids, do let me know another one. Everyone has to participate in this reaction. Then only you will be able to understand. Second is reagent. And then the reaction is going to take place. Then we will get the product formation will be there. Now kids, this is substrate or reactant, this is reagent. Two types of things are there. You can consider these two types of things just like a car is moving. Let us suppose this is car. Zoom out. Ding, 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 ding. This is car. Yay. Is it good or not? Hey kids, do let me know. These are the tires of the car. Tick, 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 tick. So in this car, Mr. X is there and Mr. X, and this is what to say, Mrs. Y. Mrs. Y or Mrs. X. So let me call it Ramu. This is Ramu, our favorite Ramu, and this is Alia. Ramu and Alia. Right now they are in Chandigarh. And they are going to Shimla. They are in Chandigarh and they are going to Shimla. Okay. Right now, two types of people are there. One is Mr. X. No, Ramu and Alia. They are going to Shimla. So they have started from Chandigarh. They reached to one place known as Pinjore. Let us suppose 35 kilometers from Chandigarh. Now, Ramu said, hey, Alia, let's have coffee. Ramu said, hey, Alia, let's have coffee. Alia said, okay, Janu, let's have coffee. They have coffee, okay. Then after moving from Pinjore, they have gone to Kasoli. Let us suppose 40 kilometers away from Pinjore. Then Alia said, oh, Ramu, let's have lunch. Ramu said, okay, Janu, let's have lunch. They had lunch and then after they reached to Shimla. 50 kilometers away, right? In this way, the car was moving. So how fast the car was moving, where they are staying and when they are moving was decided by only Ramu or by Alia or by both. Kids, do let me know. This was decided by only Ramu, only Alia or by both. Kids, now it's your chance. Do let me know. This is decided only by one or both. Only Ramu? No. Are? Killer signs, how only Ramu? Ramu was saying, let's stay over here. Then Alia was saying, let's enjoy lunch. Kids, this is not fair. This coffee was decided by Ramu. This lunch was decided by Alia. So, by both. Kids, when number of people, those who are sitting in the car, both of them, they are deciding, both of them are deciding, then the speed of car, that means rate of reaction is equal to concentration of Ramu as well as power of Alia. Both were having same power. See, power. We will talk in chemical kinetics the power. So power of Ramu and power of Alia, both were having same powers. It's not like Ramu was deciding, only Alia was deciding. Both of them were deciding. So we will say that rate of reaction is directly proportional to the concentration of reactant as well as concentration of reagent. Both of them are deciding the rate of reaction. So the how fast the car is moving, that is the speed, the rate, concentration change, time taken, distance traveled, like distance traveled, time taken. So like that, people, are you able to decide that in SN2 reaction, rate of reaction depends on the concentration of both the reactant as well as the reagent? Kids, do let me know. Kids, do let me know, are you able to understand in this way? I'm not telling you the organic chemistry, I'm telling you simultaneously the chemical kinetics basics also, kids. These are the chemical kinetics basics also. So everyone see, for SN2 reaction, everyone, tararara, say along with me that SN2 reaction, rate of reaction is directly proportional to the concentration of substrate, that is reactant, as well as reagent. So do let me know, kids, everyone, do let me know such a type of car where husband and wife, boyfriend and girlfriend, or whatever the two types of peoples are going, and both are deciding, so the car will move fast or the car will move slow. Suppose another car where only husband is deciding, wife is saying, hey, you're not listening to me, whatever I'm saying, you're just ignoring me. So that car will be dangerous car. Wife will start beating, hey, do boom. Now the car won't be able to move. Such car can't move fast. But this car, where both of them are deciding, that means this car is going with the choice of both of these two people. This car will move fast. Kids, do let me know, this car will move fast or slow? This type of car will move fast or slow, kids? Now the ball is in your court. Kids, do let me know, this type of car will move slow or fast, where both are deciding. Everyone, do let me know. Everyone, do let me know. Hey, everyone, do let me know. Fast moving car. So this type of reaction is fast reaction. SN2 reaction is fast reaction. Single step reaction. No intermediate is formed in this reaction. No intermediate formation. When no intermediate formation, that means no rearrangement will take place. This reaction will move without any rearrangement. No intermediate formation means what? No intermediate formation means no rearrangement. What do you mean by rearrangement? No rearrangement. Kids, do you know rearrangement? Hey kids, let me know. Do you know rearrangement? That is no ring expansion. Kids. No hydride shift. Have you heard these names? No methyl and hydride shifts. Hey everyone, do let me know. Nothing of these will take place if you are able to understand. Kids, do let me know. Wow, Gayatri, Mamu, such a wonder guy you are. Thank you. Hey, yes. Now kids, fast and furious. Yes, Srinath's fast and furious. Now let me tell you, the panda is also there. That's really fantastic. Everyone see to it. Now, before I start this reaction, see to it. Everyone see to it how the reaction is going to take place. See everyone. Let me write down one reaction. let me write down one reaction. Suppose if I say C X, is there any difficulty over there, kids? Yes, there is Cold War going on. Sometimes in the friendship, it's looking like friendship. The world knows it is friendship, but the two who are joined, who are combined, who are bonded, they knows that yes, Cold War is going on. That's why it is used to say that what alone, to remain alone is better than pressurized friendship. To remain alone is better than pressurized bonding. Now see, this X is having delta negative, this carbon is having delta positive. There is Cold War going on. Cold War is going on. X is saying, hey, I will go away from your life. Carbon, I will go away from your life. Let me tell you one thing. Those who are new, just understand one thing very clearly, kids. According to me, atoms, I treat human beings. Atoms are human beings. And electron is money. Electron is money. Kids, I don't know chemistry. But I will let you know each and everything only with these two things. Atoms are human beings and electron is like money. So this X is saying, hey carbon, I will go and I will take this money along with me. Carbon is saying, oh X, you want to go away from my life? Please don't go. I can't live without you. X is saying, okay, let me see to it. But one day in their town, somebody has taken the entry. See, Inu. This Inu was also having Cold War. This Nu said to carbon, Nu approached carbon. Hey carbon, I'm interested to come in your life. I want to come in your life. Hey carbon, I want to be yours. X is saying, hey, I want to be yours. This X is saying, hey, I don't want your money, but I love you. Nu is saying, I'm coming, I'm rich. I'm richy rich. I will come along with money. You don't have money. Oh, you are deficient. Money deficient. I will give you money. Money deficient. I will come in your life and I will give you money also. Kids, are you able to understand? Hey kids, first of all, do let me know this language, in what language I'm teaching you chemistry. Everyone, are you able to understand? First, do let me know. If you're not able to understand, then I will say, oh, this is carbon. This bond is eliminating. This bond is breaking. I will teach like that. But if you are able to understand, this is the best way that I'm teaching little much. You are able to understand the whole thing. Kids, everyone, do let me know that this is the best way or not. Right now, because this is tough concept, I have to teach like this only. Otherwise, you won't be able to understand. Maja aa raha hai, Ashish Kumar is saying. Shubh Shri is saying, superb sir, Kanksha, yay. Sir, I request you one thing. Please help me. Gayatri Mo, please ask. Oh, it's nice. It's nice. Everyone, then show me the thumbs up. If you're liking it, if you're liking this way, then welcome it by showing the thumbs up, kids. And what is this? Only 39 likes, kids. Hey, this is not fair. You don't love your HSP, Baba. I want to see the increase of likes. Wow, Panda is saying the best. Oh, Akansha, everyone. Now see. So, they have decided to leave. Now see, this carbon will be of Nu. It will be now known as Kanu. And this E will be of X. In this way, this marriage has taken place. But kids, let's see the stereochemistry of this reaction. This is not so simple. Once if you go to see the movie, For 3 hours, complete 3 hours, you will see the movie, and when you are going to come back, somebody is asking, hey, what happened in movie? You will say, oh, one hero was there, one heroine was there, they got married. But if your close friend is asking the same thing, you will say, oh, what a entry of hero, what the entry of actress. Now there was some obstacle, and like this and that, the movie was moving like that. Now see kids, the stereochemistry. Stereochemistry of this reaction. Everyone, let's focus the stereochemistry of this reaction. Stereochemistry. See everyone, focus over here. This is carbon. One bond is coming towards observer side. This is being wedge formula, flying wedge and dash formula I am going to draw. This valence is coming towards observer side, and this is going away from observer, and this is in the plane of paper. These two valences are in the plane of paper. This is coming towards observer side, and this is going away from observer. This is now here is halogen. Here is halogen having delta negative and delta positive, because this atom is being more electronegative atom. This is being more electronegative atom. More electronegative atom, kids. Now this has to leave, so this is known as leaving group. Leaving group Lg. Lg, I will say leaving group Lg. And this is the bond. This is the bond. This is known as bonding molecular orbital. Bonding molecular orbital. And just at the back of bonding molecular orbital, there is ABMO. ABMO. What do you mean by ABMO? Anti-bonding molecular orbital. This is being vacant. Vacant. Number of questions will come from here only. Number of questions. Now kids, in the life of this, who is going to come? Who is going to come? E nu. E nu. Now kids, do let me know, is it possible that nu can attack from here? Always remember that when somebody is going to donate electron, electrons are always donated in vacant orbital, not in the filled orbital, because one orbital can hold maximum of 2 electrons. So all the four bonds, they are having already two electrons, two electrons. So this Nu cannot donate electron from this side. So do let me know from which side Nu. Nu means nucleophile will approach. Everyone, do let me know from which side Nu will come. Can't come from front side. Nu has to come from back side, exactly from back side. Attack. This back side attack. See how the Nu will come. See, let me show you kids. Let me show you. See everyone, try to understand. Let us suppose this is X. This is X, and this my hand is carbon. This X is there in the attached with carbon. Okay, this is carbon, and this is Nu. Nu. Everyone able to understand? This is Nu. Now this will come from the back side. Get. Now it will attack. Now if this is weak, it can't be able to displace this X from the life of carbon. But this has to be strong. If this is strong, it will hit. Doom. Yay! Now from the life of carbon, X has gone and this Nu has occupied the position. Kids, everyone do let me know, this nucleophile should be strong or weak? What do you think? Strong nucleophile is required or weak nucleophile is required? If this is strong, then only it can displace this X. It has to be strong. It has to be strong. This is known as backside attack. Backside attack, kids. This is known as what? Backside attack. I hope that everyone is able to understand kids. Backside attack. Now, when it is going to do backside attack, there is one transition state. When the nucleophile was hitting, kids, let me tell you, when this nucleophile was hitting, there was one transition state. At this time in the life of carbon, how many valencies were there? Do let me know. At this time when this was hitting, this, how many valencies were there? See, 1, 2, 3, 4, and the nucleophile will come and attack from the back side. At this point of time, how many valencies were there in the life of carbon? 5 valencies, kids. 5 valencies. Are you able to understand? So let me draw the transition state. Let me draw the transition state. See, this is carbon, this is R1, this is R2, this is R3, and from the life of this carbon, one is going and one is coming. One is going and one is coming. You see, the who is going? X is going from the life of carbon, and this Nu is coming from the back side in the life of carbon. Now, at this point of time, the carbon is having pentavalency, pentavalent. Now, kids, examiner will ask, what is the hybridization? At this point of time, what is the hybridization? Examiner will ask, what is the hybridization? You will say sp3d. No, kids. Only these 3 valencies are responsible for hybridization. Only these 3 valencies are 1, 2, 3. So sp2 hybridized. This is the answer. It has been asked 3 times in the IMS examination. Now, carbon is pentavalent. Carbon's mummy said, you are very small. Don't keep more than 4. Neither less than 4 nor more than 4. But in the life of carbon, there are 5. Mummy is saying, what are you doing? Just remove 1. You are feeling highly unstable. So this is pentavalent carbon. Pentavalence. Valency is 5. So transition state, highly unstable. Highly unstable. Kids, in this state, this bond is breaking. Bond is breaking. And this bond is breaking. And this bond is getting formed. Bond is making. So simultaneous making and breaking. Can you understand? This is the state where simultaneous breaking and making. Simultaneous breaking and making is taking place. Now, kids, try to understand what is going to happen now. Everyone see to it. In a short while, from the life of carbon, X has gone. This is R1 coming towards observer side, but the side got changed. See, kids, this was on the left hand side or west side, but has gone to east side. This is your R2, this is your R3, and in the life of carbon, who has taken the entry? Nu. Kids, are you able to understand? This is inversion of configuration. This is inversion of configuration, like umbrella inversion. Inversion of configuration. 100% inverted product is getting formed. Kids, do let me know, are you able to understand what do you mean by inversion of configuration? Just like umbrella is like this. This is your umbrella, and when the wind is there, so the umbrella will get like this. Hey, umbrella, what happened to you? This is like umbrella inversion. So the inversion of configuration. This is inversion of configuration. Kids, if you are able to understand, do let me know that yes, you are able to understand. You got it. You got it. Everyone got it. Now, sir, see, sir, are they isomers? Oh, Jyoti, I am going to give you one question on your comment only, right? Are the isomers? No, kids. See, once the question has been asked in IIT as well as in AIMS based on this only. See, everyone. The question was like this. This is a question of AIMS, and already this question has been asked in AIMS as well as IIT. Both of them, they have asked the question. See, the question was like this. This is your reactant CH3 C2H5 hydrogen Br, and it was allowed to react with C2H5ONA, C2H5ONA. This was the reaction given. Now they have given this is dextrorotatory. This is dextrorotatory. The SN2 reaction is going to take place and the product will be formed. Now, what is the product? Product is dextrorotatory or levorotatory, or data is insufficient, or we cannot say. Now, see, kids, what product you are going to get? Try to understand. You will get this product. You will get this product. This Br will go C2H5 CH3 hydrogen, and this will be the position occupied by OC2H5. ET means ethyl. This is chiral carbon. This is chiral carbon, kids. That is also chiral carbon. This is also chiral carbon. Both of them are chiral carbon. But if this is dextro, what do you think the product will be? Do let me know in the chat section. Product will be dextro, levo, or we cannot say. Yeah, this is Williamson synthesis. Oh my God, Jyoti, you know very well. This is, yeah, this is known as Williamson synthesis. Definitely, this is known as Williamson synthesis of ether. Yes, Williamson synthesis of ether. I will let you know in detail. But right now the question is, the product is, this product is first option, dextro, levo, or we cannot say dextro, levo, or we cannot say levo. Everyone is writing levo, kids. Everyone is writing levo, and 99% students, they have given answer to be levo. 99% students have given levo. Examiner will give you 0 marks, 0 marks, 0, big 0. Now ask me why. Everyone, ask me why. Because, yeah, Akanksha is right. We cannot say. See, in this compound there is bromine and here is OC2H5. What do you think? These two compounds molecular formula is same or different? These two compounds molecular formula is same or different? See, this is Br and that OC2H5. These two compounds molecular formula is same or different? Different. So product is not the isomer. Product is not the isomer, is not the isomer of reactant, is not the isomer of reactant. When product is not the isomer of reactant, we cannot correlate. So we cannot say this is dextro or levo. This can be either dextro or it can be levo. Everyone is able to understand the Pada, Vidha Janani. Everyone, do let me know that everyone is able to understand. Once we know this is R or that is S, that we can say very well. See, we can find out the configuration. See, number 1, number 2. The arrow is moving clockwise. Clockwise arrow is going, and this LPG, least priority group, is over here. We will say this is R configuration. We can say this is R configuration. Its configuration, number 1, number 2. The arrow is going arrow is going anti-clockwise and hydrogen is over here. This is S configuration. If R is dextro, then L will be levo if they are isomers. If R is dextro, then L will, if R is dextro, then S will be levo. But if they are isomer, but these two are not isomers, so we cannot say the configuration of this compound will be what? Because the reactant and the product are not isomers. Kids, everyone is able to understand? Have you got it? Everyone, have you got it? Now see. Now see, kids. One mind-blowing reaction of SN2. See, mind-blowing reaction of SN2. First, let me tell you one most important point. In SN2 reaction, do you let me know racemization will take place or not? In SN2 reaction, racemization means if the reactant is dextro, then product should be the isomer. Okay, one kid is asking, Nidhi Pawar is asking, sir, give some examples of this question. Okay, I will tell you this question later on. Okay. First, let me tell you simple example. This tough one I will tell you later on. Now see. First of all, factors affecting. Let me tell you factors affecting rate of SN2 reaction. Rate of SN2 reaction. Kids, everyone, you have to tell me, if I am saying this is carbon, this is halogen leaving group, this is another valency R1, R2, R3. Now, what do you think? This nucleophile can attack easily from the back side. This nucleophile can attack easily if these R groups are small or bigger. Do let me know. These R groups are small, least sterically hindered, or sterically hindered. How the nucleophile, in what condition the nucleophile is going to attack easily? Kids, do let me know. The type of R should be small. Killer signs, very good. So the first condition for this reaction to take place, type of R must be, kids, do let me know that rate of reaction is inversely proportional to the size of reactant. Agreed or not? So what type of R is required? So R must be least sterically hindered. This is the number of times asked question, kids. Now see, if I say if R is methyl bromide, then will be the rate more, or ethyl bromide, then will be the rate more, or isopropyl bromide, then it will be more rate, or tertiary butyl bromide. Kids, do let me know in which case the rate will be maximum rate will be in which case, kids? Definitely the rate of reaction will be in this order. This will be the rate of reaction. Maximum in this case. This will be the order of rate of reaction. Rate for SN2 reaction. Everyone is able to understand? This is least sterically hindered, and that here the rate is 0.00001, means negligible, no reaction SN2. There is no SN2 reaction, kids. And in the NCERT, the data is given, if this is going to react 1 times, then it has 30 times more, and it has 0.02 times more. That means this is the best choice, and this is known as 1 degree. This is known as 1 degree. Both of these are known as 1 degree alkyl halide. 1 degree alkyl halide is the best choice for SN2 reaction. And tertiary will not give you SN2, will not give SN2 reaction, will not give SN2. Everyone is able to understand? Let me see, my dear kids. Are you getting it or not? That tertiary is the best choice, and the 1 degree alkyl halide is the best choice for SN2 reaction to take place. Yeah, SN2 reactions are inversely proportional to steric hindrance. Steric hindrance plays a role, yes. So the rate of SN2 reaction is inversely proportional to steric hindrance. Everyone, now see kids, this is for top 100 rank. Now I am going to tell you concept for top 50 rank. Concept for top 50 rank. Concept for top 50 rank reaction. Top 50 rank. Target is Ames tally. Ames tally. If your target is Ames tally, then only try to understand. Whenever you are having heteroatom at beta carbon with respect to leaving group, heteroatom at beta carbon with respect to leaving group. What is this? See, if I write here carbon, bromine, and if I write here this is alpha carbon, this is beta carbon, I have written oxygen, CH2. Now see, this is bromide, leaving group, this is leaving group, this is alpha carbon, this is beta carbon, and this is heteroatom. It can be given like this, or it can be given like this. See, R C double bond O CH2 Br. It can be BrCl, can't be fluorine. X can be chloride, bromide, iodide. What can't be fluoride? I will let you know why not fluoride. Now see, this is being alpha carbon, this is beta carbon, and this is being heteroatom, kids. These type of atoms, you will get shocked to know that methyl halide was having rate 30 times, and they have rate, let me tell you, 10 raised power 6 times more. 10 raised power 6 times more rate for SN2, and the reason is neighboring group participation. The reason for it, neighboring group participation, that is not in your syllabus, but yes, who is going to show SN2 with maximum rate? This is being in your syllabus. So remember that its reason is NGP effect. What is NGP effect? Neighboring group participation. NGP means neighboring group participation, but not in our syllabus. Neighboring group participation. No, participation. No, what is in syllabus and what is not in syllabus, kids? The reason is not in syllabus. This reason is not in syllabus, but this reactant is in your syllabus. Examiner will ask you. So let me give you the full chart for the type of R, kids. Now, the full chart for type of R, see to it. Type of R, keep in your brain. This is going to help you a lot, kids. Type of substrate. So at the first position, who is going to come, kids? Heteroatom at beta carbon. Heteroatom at beta carbon with respect to leaving group, beta carbon with respect to Lg leaving group. So these are the examples. You have to keep it in your brain. R O CH2 CH2 X, or it can be R NH CH2 CH2 X, or it can be R sulfur CH2 CH2 X, or it can be R C double bond O CH2 X. All these are beta hetero, and the degree of these are 1 degree. These are 1 degree, 1 degree alkyl halide. And after this, methyl X, this is also 1 degree. After this, ethyl X, this is also 1 degree, kids. All three are 1 degree, but their rate is different. Its rate is 10 to power 5 times more. This is 1. No, this is 30 given in NCERT. This is given in NCERT, and this is 1. And this is not given in NCERT. Missing part of NCERT, kids. This is missing part of NCERT. Missing part of NCERT, and that's why kids are not able to get the rank. And this is the reason why kids are not able to get the rank. Now, after this, 2 degree is very less amount, 2 degree very less amount, and 3 degree doesn't show SN2. 3 degree doesn't show, no SN2, no SN2 reaction, negligible SN2 reaction. So this is the complete chart, kids. Now, if I talk about substrates, R part I have told you, but substrate is made up of 2 parts. One is being R and one is being X. Our substrate is made up of 2 parts. Substrate is made up of 2 parts. Is made up of 2 parts. Just like pen, See this pen. Is this pen 1 part? No, this pen is made up of 2 parts. See, one is the cap, one is R. This is R, this is X. X is the leaving group. Sometimes you are going to lose this cap, isn't it? Sometime you are going to lose this cap, RX. This is RX, and this cap is mobile, very good leaving group, then it will leave itself. You won't be able to search it, kids. Now see, substrate is made up of 2 parts. What are these 2 parts? One is being R, the alkyl part, and another one is being X, the leaving group. X, the leaving group. Now, what do you think? From the life of carbon, X wanna go and new wanna come. Kids, do let me know. From the life of carbon, see, from the life of carbon, who wants to go? X wanna go, and new wanna come in the life of carbon, and you wants to come, backside entry, and this X wanna go, leaving group. Which X can go easily? The one who is loosely bonded or strongly bonded? If this X is loosely bonded, then it will go fast, or strongly bonded? Kids, too, let me know. Yeah, Akash, I will tell you each and everything. But first, do let me know which X can leave easily, the strongly bonded or the weakly bonded. Which X will leave? Loosely bonded. Yes, loosely bonded will lose fastly. Loosely bonded. Hey, loosely bonded X will leave fast. Now try to see who is loosely bonded and how to decide. Now see, kids, we have to know a little bit of periodic table. See, if I write fluoride, fluorine, chlorine, bromine, iodine, you know, fluorine, chlorine, bromine, iodine. If I say the size of fluorine, is like this. If I say the size of fluorine is like this, then chlorine is like this, then bromine is like this. So flash, see, bromine, and the iodine is like this. Oh my god. Now carbon is like this. See the size of carbon. The carbon is being like this. The size of carbon is like this. See kids, this is carbon. If I talk about periodic table, see, this is second period, this is third period, this is fourth period, this is fifth period. You know, bond of equality is good. This thing you know very well. Bond of which is good? Bond of equality is good. Bond of equality is good. Am I right or not? Bond of equality is good. Hey kids, do let me know. Are you agreed or not? Bond of equality is good. And if you don't remember this, then Florida to Florida, bro and I. Do remember this mnemonic? Florida to Florida, bro and I. Florida to Florida, bro and I. Now, this and this. Hey, I love you too much. We are of equal size. Hey, we are of equal size. These two are approximately of equal size. Approximately of equal size. So, carbon will say, fluorine, I am not going to lose you. Carbon will say, fluorine, whatever the nucleophile is going to come, I am not going to lose you. A friend in need is friend indeed. So this reaction is not possible, not possible, not possible. This reaction is not possible, kids. This reaction is not possible. Now, this is 2p, this is 2p, this is 3p, this is 4p, this is 5p. If iodine is bonded with carbon, iodine is saying, hey carbon, what are you? You are very small. I'm too big. Very, very big in size. Carbon too small, too small. What do you think? This friendship is good? This bond is good? Iodine say, hey carbon, you are very small. Carbon saying, you are too big. Just go. Go from the life. So iodine will say, oh, I'm going. Carbon saying, just go away from my life. I want to search somebody else. Now see kids, this was the question asked in NEET, IIT, everywhere. See, question. Arrange the following in decreasing order of, arrange the following in decreasing order of rate. Now see, first reaction, everyone has to answer the correct answer. I'm waiting for the correct answer. The A is CH3 F C2H5 ONA. DMSO, I will let you know what is this DMSO. About DMSO, I will let you know. Second B reaction is CH3 chloride C2H5ONA, and same thing. C is CH3 I plus same, reach of everything is being same, and D is CH3 Br, and these are being same. Kids, do let me know. Now it's your turn. The ball is in your court, kids. The ball is in your court. Which is having maximum rate? I'm not going to give the options. I want to see, oh, one student, aspiring medico Divojit, has given the answer IBR. Oh, so it all depends. Leaving group tendency. See kids, this is common. This R is common. R is common. Nucleophile is common. So what do you think, which is having best leaving group tendency? This iodine will leave first. C, after C, D, C, D, B, and I would like to say A so is not going to leave. Kids, this is the rate of reaction. Everyone agreed or not? This is the rate of reaction. Everyone agreed or not? Kids, do let me know. Are you able to understand? Are you able to understand or not? CDBA, oh my God, Linnea is there, Killer Science is there, CDBA, right? Should I give you another question of same question, which a question is going to come in examination? Are you ready? See, another question. Now this was based on what? This was decided on the basis of LGT. What is the full form of LGT? LGT means leaving group tendency. Leaving group tendency. Everyone is able to understand. Now I am going to give the best awesome question. See, once again arrange the following in decreasing order of reactivity. One is this, A1 is CH3 O CH2 CH2 I. B is CH3 CH2 CH2 I. C is CH3 C CH3 CH3 I. D is C H H H I, and they all are reacting with CH3 ONA. Same nucleophile for all the four. Kids, do let me know what answer you are going to give. I'm waiting for your answer. Let me move aside and try to find out. Do it clearly. I don't want the wrong answer, kids. Hey everyone, do let me know. And kids, I'm the one who is teaching in Avengers batch. The whole team, me, Wasim sir, two chemistry teacher, world's renowned teachers, physics, Shreyas, the best teacher of physics, and your bio ma'am, Ambika ma'am. And today is the last day for the registration in Avengers batch. After this, you won't be able to take admission in Avengers batch. So kids, do remember, all four teachers, best, India's best team. Now I want to see, kids, what's your answer? A, D, B, C. Akanksha Singh is going to give answer A, D, B, C. Some are giving. Killer Science is going for D, B, A, C. Vijay Lakshmi, oh my God, how the answers are getting changed, options are getting changed. See, kids, first C. See everyone, this one, the first one is alpha, beta, heteroatom. Oh, heteroatom. This is on number one, kids. This is going to be on number one. Everyone see, A should be at number one. A should be at number one. Now see, this is methyl halide, least sterically hindered. Then D, A, D. Then this to last, B, B, and last is C. If this is your answer, show me the thumbs up. If this is your answer, kids, if you got the correct answer, you are going to rock in NEET examination. Do let me know. Is this your answer? ADBC. ADBC. Oh, great. Akanksha, ADBC. Jyoti, wrong. Nidhi, right. Inya, right. Oh, those who got the correct answer, show me the thumbs up. Otherwise, thumbs down. Kids, thumbs down. Now see. The leaving group tendency we have seen weaker basis. If you are not able to understand, let me tell you leaving group tendency in another way so that you can keep it in your brain. Leaving group tendency. Leaving group tendency. If you are not able to understand, let me tell you weaker bases are good leaving groups. Weaker bases are good leaving groups. Good leaving groups. Weaker bases are good leaving groups. See, the another criteria we have just seen that if I write HF, HCl, HBr, those who are not able to understand, let me tell you another way, another technique, the best way, the second visualization for doing the same question. There's also one another way. See, we know the acidic strength. This is the acidic strength order. Hi is maximum acidic, gets Hi is being maximum acidic, and this is being least acidic, this is being least acidic, least acidic. So what I said, weaker bases, and once I've told you stronger acids form weaker conjugate base, stronger acids form weaker conjugate base, weaker conjugate base, right? This already I've told you in GOC. So this is the strongest acid, its conjugate base will be weakest base, weakest base, and weaker bases are good leaving group, and this is going to form strongest base, strongest base, strongest base. Now kids, this is all about the leaving group tendency, but examiner, if examiner is going to ask tough question, then let me tell you the leaving group tendency whole order, kids. This is on the basis of mind. Now let me give you the table for leaving group tendency so that you should not get negative mark in any question, kids. Leaving group tendency. Before I move towards leaving group tendency, this order, everyone do let me know, have you heard the name Avengers Batch? Do you know Avengers Batch, kids? Have you heard the name Avengers Batch? And those who have heard the name, ask these kids. First, they were thinking that I'm a bored person. Before studying from me, before knowing HSP Baba, they were thinking that he is a very strict person. They were thinking like that. He is a rugged person. But once they are studying in Avengers Batch, now as these students, they are saying, sir, you are God of chemistry. We have never seen such a great teacher. And not only for me, the whole team. Let me tell you the same words for the whole team, kids. And they were saying that, sir, if we have got you earlier than Riyaz, sir, we would have been the best doctor. We must have got the great college. Agreed or not, kids? If anyone is here from Avengers Batch, the best team, the world's best team is teaching us over there. And kids, if you think chemistry pedicure Radu customer, if you think organic chemistry pedicure Radu customer, then I would like to say, LA, it's Romba Sulbham. LA, it's Romba Sulbham. That means organic chemistry is not tough. If I'm here, HSP Baba is here. Kids, if HSP Baba is here. Now see, leaving group tendency. Let me give you the whole series. Trick, I'm going to give you the trick. See, tricky order. Tricky order for leaving group tendency. This is the leaving group tendency order, kids. You have to understand it for tough questions. Now the thing, let me tell you, everyone, these four are very, very strong bases. Very, very strong bases, very, very strong bases. So, not a leaving group, not a leaving group, or very, very poor leaving group. And that's why, kids, let me tell you, whenever you are going to deal with these four, RNH2, ROR, ROH, RF, they are not going to show you reactions easily, kids. Now, if you want to say, if you want to apply your brain, just add proton to this and you will see who is being stronger acid, who is being weaker acid. You will get the answer. Now, it's over here, it's over here, it's over here. Now, you must be thinking of tosylate, mesylate and triplet. What are tosylate, mesylate, triplet? You want to know? Hey kids, do let me know you want to know what is tosylate, what is mesylate and what is triplet. So let me tell you what are these tosylate. If I talk about tosylate, kids, then I would like to say its name is paratoluene sulfonate. Paratoluene sulfonate. This paratoluene sulfonate is very, very good leaving group. It's very, very good leaving group. Very, very good leaving group. Now you will ask why it is being very, very good leaving group. Let me draw the structure of paratoluene sulfonate. See, this is paratoluene sulfonate. Now see kids, sulfuric acid, RSO3H is very, very strong acid. You know very well, RSO3H is very, very strong acid. Why it is being very, very strong acid? Because its conjugate base is highly stable, most stable conjugate base. Why it is being most stable? Because of three equivalent resonating structures, three equivalent RS. So this is going to be very, very good leaving group. This is being paratoluene sulfonate. Whenever you get, now see, it is represented like this, ROTS. You will see a number of reactions, ROTS. So this is tosylate, this OTS, this is OTS, tosylate, OTS. So whenever you see this group, this is going to be the best leaving group, and this is really very, very important for SN2 reaction. Now see kids, the most important part I am going to tell you, you have seen in SN2 reaction, it is going to take place in single step. So whatever the product was formed, that was not the isomer of reactant. So if examiner is asking, what do you think in SN2 reaction, racemization do take place or not? So this is the question. You have to tell me true or false. True or false, kids? True or false? Do let me know true or false, right? True, false. Apply your brain and do let me know, kids. True, false. In SN2 reaction, racemization do not generally take place. Generally take place. This is statement in front of you, kids, and I'm hoping that you are going to tell me the correct answer. This is rank deciding question. This is going to be rank deciding question, kids. This is really rank deciding. Rank deciding. Those who want to have rank, then you can go for this rank deciding. Rank deciding. Kids, do let me know. True. Akanksha Singh has given that it's true. Yes, kids, hurry up. Fast, quick, true. Priyanka is saying true. So this statement is absolutely true, kids. But you see, whenever the generally word is used, whenever anyone is going to use generally word, that means there is something catchy, there is something fishy, isn't it? isn't it? The examiner has used in SN2 reaction, racemization do not generally take place. That means there must be some example. There must be some example which is having racemization. Now see, mind-blowing example, world's mind-blowing example I am going to give you, kids. World's mind-blowing example. Mind-blowing example. What is something special about this example? Let me tell you. Example of SN2 reaction in which racemization do take place, in which racemization takes place. Kids, have you ever heard about any reaction of SN2 where racemization do take place? Do you know? Let me give you that example. See, kids. See to it, kids. This is being iodine. This is being methyl. This is being hydrogen. This is being ethyl. You can see very clearly this carbon is being chiral carbon. Can you see this carbon is being chiral? Now, if the reaction is going to take place with NaI, if the reaction is going to take place with NaI, kids, see, if the reaction is going to take place with NaI, now what is going to happen, kids? What is going to happen? Do let me know. That this is good leaving group. We know very well. Good leaving group. Good. Why it is good leaving group? Who is making to be good leaving group, kids? Because this carbon is 2p and iodine is 5p. Too much side difference. Very, very poor overlapping due to very poor overlapping. Due to very poor overlapping. Am I right, kids? Am I right? Yes. So definitely this iodide will leave, and this iodide will come from which side? This will come from back side and attack on ABMO, anti-bonding molecular orbital. Then there will be inversion of configuration. In case of chiral carbon, the inversion is known as Walden inversion. This inversion is known as Walden inversion because the carbon is being chiral. So you will get this product. This is being methyl. This is being ethyl. This is being hydrogen. And this iodine will come in the life of this compound. And NaI will eliminate out. You will get NaI. Now kids, there is inversion of configuration, and because the carbon is chiral, Walden inversion. We will use word Walden inversion. Now everyone, what do you think? If suppose examiner has given this is having dextro configuration, this compound's configuration is being dextro. Let us suppose this is given to be dextro. What do you think? What the configuration that product will be having? Definitely product is going to be levo because these two are isomers. The reactant and product both of being are isomers. See kids, both are isomer, and this is the only example, only one example, special, only one special example, kids, special example where racemization is taking place. This is dextro, that is levo, plus and minus, and this reaction is being reversible. Now say kids, dextro and levo will be known as racemic mixture. Now the question arises, what is happening? This is leaving group and this is nucleophile. Then why it is going? And how to find out? It's, you know, radioactive tracer technique is there. Radioactive tracer technique is there. So they have seen that, okay, one more thing. Iodide is the only one thing. Iodide is very good leaving group, as well as very good nucleophile. Now you will say, sir, if iodide is very good nucleophile, then why it is going to leave? Its nucleophile has nothing to do with stability of bond. Nucleophilicity deals with the speed of reaction, with what speed the nucleophile is going to form a bond. For example, in your life, one is Ramu, one is Shamu. Ramu has done very fastly the friendship with you, and Shamu took time. Shamu's bond with you was very stable. Shamu, Sita, whatever the gender you can choose, that don't mind. Now, Ramu has formed a very big bond. So definitely the friendship with Shamu is very good. Ramu's friendship is not good. But Ramu will be known as the best nucleophile because the first friendship was done by Ramu. Nucleophilicity has nothing to do with the stability of bond. Nucleophilicity deals only with how fast the nucleophile has formed bond with carbon. That's it. That's it. So iodide is the best leaving group as well as best nucleophile, and that's why it happens with iodine. Do remember always iodide is best leaving group as well as what? As well as best nucleophile, as well as best nucleophile. And nucleophilicity has nothing to do with the stability of bond. Nucleophilicity means the speed, that is how fast any entity formed bond with carbon. Now kids, let me tell you all these things in detail. What is the nucleophilicity? Suppose the question is coming like this. Arrange the following. This is the best question. Frequently asked question. Question is, arrange the following in decreasing order of nucleophilicity. I, Br, Cl, F, and the question is in DMSO. You know DMSO is polar aprotic solvent. This is a really fantastic question, kids. Sir, I can score full marks in organic chemistry by following your sessions. Yeah, full. Anyone can get full marks, and not only full marks in just 10 minutes. The whole organic paper, whether it is of IIT or it is of medical, whatever the paper it is, in just 10 minutes, the whole organic chemistry. Yeah, the nucleophilicity will change in special cases, and all the cases I am going to discuss, kids. So stay remain. So kids, try to understand it. They have asked in DMSO polar aprotic solvent. Either to you can try, or should I explain? Aspiring medico Devojit is saying A, B, C, D. A, B, C, D. Everyone is saying A, B, C, D. Kids, the correct answer is fluoride, then chloride, then bromide, then iodide. Now you must be shocked. Sir, what is this? It's just coming opposite. It is just coming opposite. This is the nucleophilicity order, kids. This is being the nucleophilicity order. Now, how many of you want to understand why it is like this? Somebody must be thinking, sir, is it wrong, sir? The order, the arrows are wrong. Kids, should I tell you the detail? How many of you want to know in detail? And likes are less. Kids, first of all, smash the like buttons. How hard I am working, kids. How smartly I am teaching. I'm really working hard, kids. Everyone, please smash the like buttons. Right now they are 73. Make it to 80, at least 80, kids. At least make it to 80. Until that time, let me write down the nucleophilicity order in PAS, the nucleophilicity order in PAS, and the nucleophilicity order in NPS. But I want to see the like buttons should be, you have to hit now in PPS. PPS means polar protic solvent. Polar protic solvent. The nucleophilicity order is like this. I negative is the best, then Br negative, then Cl negative, and then F negative. This is the order, kids, in what? This is the order in polar protic solvent. Now, if I talk about the order in where? Polar aprotic solvent, PAS, that is polar aprotic solvent. Right now I am going to give you chart, then I will explain. First I am going to give you chart, memory chart, and then I am going to explain it. Okay, kids? Polar aprotic solvent. Polar aprotic solvent, the nucleophilicity order is fluoride is best, then chloride, then bromide, and then iodide, kids. This is the order. Now if I talk about non-polar solvent, NPS, that is being non-polar solvent, then the order is iodide is the best, then bromide, then chloride, then fluoride. Kids, you can see this is the order in PPS, this is the order in PAS, and this is the order in NPS. Kids, everyone, just try to understand, in all the different solvents the order got changed. Here iodide is best, there iodide is best, but here fluoride is best. What is the reason in polar aprotic solvent why the order got changed, why the order is getting changed? Now let me explain one by one. Are you ready, kids? Everyone ready? Are you ready? Yes, sir, keep going. We appreciate your hard work. So it's not touched 80, kids. Try to make it 80. Okay. Now see, first of all, I'm going to tell you about PPS. In PPS, everyone try to understand, because this is going to be really the best concept and it holds a hell lot of weightage. In PPS, what are the examples of PPS? PPS means the solvent which is polar as well as protic as well as can donate proton, So, you know, water is universal solvent. You know very well, everyone, water is universal solvent. Am I right? Because it dissolves most of the things. Now, water is universal solvent. Everyone try to understand. Now, in the market, you will get NaF, NaCl, they are as a salt, NaCl, NaBr, NaI. Now, if I talk about size, who is having biggest size in air or molten state, then we will see that if this is fluoride, then this is chloride, then this will be bromide, and this will be iodide. This is the size in molten state or gaseous state. If I talk about molten or gaseous state, this is the size, this is the order of size in gaseous state, or molten state. Now kids, before moving ahead, you just let me know one thing. I am going to give you one puzzle. You have to answer it, kids. If I say this is, there is one shark. You know shark? Shark. And here is Ramu. Now, if there is a fight in between Ramu and shark, who is going to win? There is fight in between Ramu and shark. Do let me know who is going to win. Ramu and shark, they have fight. Everyone fast, do let me know who is going to win. Do let me know. Shark, you know very well. Shark is a fish, giant fish. Who is going to win? Do let me know, kids. At least you can answer it, kids. I'm waiting for your answer, kids. What are you doing? Quick. Hey, give me the answer fast, kids. Shark. Everyone is saying shark. Kids. Everyone is saying shark. This is very wrong. See, let me give you another question. You are not able to answer it. There is one crocodile on land, and there is one lion. On the land only. Who is going to win? Definitely, lion is the winner. But if they are inside water, the same two things, if crocodile and lion are inside water, in deep water, then crocodile is going to win. So kids, it depends. Who are you is not that important. Where you are is more important. Kids, who are you is not that important. Where are you is more important. So it depends. Where are you? It's more important. That where are you? Then who are you? Then who you are. Am I right or not? Everyone agreed or not? Is everyone agreed or not, kids? Everyone agreed or not? Yes. So this is more important. Now see, kids, I've told you In gaseous state, this iodide was saying, hey, I'm the biggest, I'm the biggest, I'm the biggest. Iodide was always saying, I'm the biggest. But once they have gone inside the water, they all went inside the water. Now see what is going to happen. They all gone inside the water. So they took entry inside the water. You know, water loves. Water is like mother. Water is like mother, kids. Water is like mother. Always, water is like mother. Everyone, do let me know. Mother loves whom much? The small kid or the big kid? Always, mother loves all son. Whatever the number of sons the mother is having, mother will spread the love to all, each and everyone. The smaller one needs more. So mother loves smaller one more. Over here you can see fluoride is smaller. Fluoride was like this. The size of fluoride was like this, kids. Only this much. But water is saying you are smaller, you are having maximum charge, smaller size, maximum charge. So water is going to form intermolecular hydrogen bonding. Water is going to form intermolecular hydrogen bonding. Kids, are you able to understand? So water will surround it from all these sides. Water is going to surround it from all these sides. Now the size of fluoride will be this much because of maximum hydrogen bonding, intermolecular hydrogen bonding, maximum hydration due to maximum intermolecular hydrogen bonding. Kids, everyone getting my point? Now, this was the size of iodide. This was the size of iodide, but size of iodide is very big in the gaseous state. So only few molecules of water will come. Only few molecules of water will come. 1 or 2 molecules of water will come and surround it. Now its size is like this. Now who is bigger in water? Kids, do let me know who is bigger in water. This is bigger after solvation. Bigger after solvation. Can you see? Biggest after solvation. Now, mother has provided the shield from all the side, and this is the smallest in water. Smallest in water. You must have heard one song in Hindi. You must have heard one song in Hindi. वो जो कहते थे बदलेंगे ना हम कभी, वो जो कहते थे बदलेंगे ना हम कभी, क्या से क्या हो गए देखते देखते. So it was largest in size in gaseous state, but the largest has become smallest in water. So this is all due to solvent. That solvent has made biggest to be the smallest and smallest to be the biggest. So it always depends, kids. Now who will run fast? Have you heard this song? Have you heard this song, kids? क्या से क्या हो गए देखते देखते. The one who was saying I will not change. The one who was saying I will not change and never change. But how he or she got changed. Now kids, try to understand. Water is like mother, loves smaller more. Loves smaller one more, smaller ones more, right? So kids, in water, this is smallest and this is largest, so it will move fast, will move fast, will move fast, and will move slow, will move slow, will move slow. It is like Michael Jackson and that is like Milkha Singh. That is like Milkha Singh and this is like Michael Jackson. Now see kids, everyone. Everyone see to it. In water or alcohol or carboxylic acid, they all are examples of what? Polar protic solvent. These all are examples of PPS. And remember, or when no solvent is mentioned, or when solvent is not mentioned, then always consider that iodide is the best nucleophile, then bromide, then chloride, then fluoride. Because in aqueous state, if I write aqueous, this aqueous, this aqueous, this is not going to help you over here only. It will help you in physical chemistry, electrochemistry chapter, ionic mobility. When you go to inorganic chemistry, yes, once again the question will come, who is bigger in size, who is smaller in size. If I write aqueous, then who is smallest? Aqueous I negative is smallest in size, get smallest, and this is being largest. Agreed or not? Everyone agreed or not? So this is the order of nucleophilicity. Gets, this is in PPS. Polar protic solvent solvates both the cationic as well as anionic part. Do remember, it will solvate. Wow, Deepa is there. Most of the students, they are liking it. So always remember that kids, this solvates, PPS solvates both. PPS solvates both cationic as well as anionic part. Cationic as well as anionic part. Now kids, now it's a turn of polar aprotic solvent. Everyone, PS, are you ready to understand PS? Because it will require some brain. It will require some brain. Polar aprotic solvent means solvents which are being polar, solvents which are being polar but can't donate proton, but can't donate proton, donate proton, but can't donate proton. Kids, everyone ready? Is everyone ready to understand it? Now see kids, if I write down DMSO is the example, DMSO, you will say, what is this, sir? I will say dimethyl sulfoxide, dimethyl sulfoxide. Once again you will say, sir, what is this? I'm unable to understand what is this dimethyl sulfoxide. I will write CH3, S double bond O. This is DMSO. Whenever you get DMSO, or let me write down DMA. DMA, what is DMA? Dimethyl acetamide, dimethyl acetamide. What is dimethyl acetamide? See, dimethyl acetamide. Acetamide is what? Acetamide is CH3, C double bond O, NH2. This is acetamide, ethanamide. Can you see? This is acetamide or ethanamide. Now if I place CH3, this is dimethyl acetamide. More examples. Dry ether. Why dry ether? No water should be there. Dry ether. Now see kids. One more, DMF. If I write DMF, dimethyl formamide. How it looks like? C double bond O N dimethyl formamide. Now why I'm writing all these? Because you will get in your examination. Now see kids, the most important thing. PAS, polar aprotic solvent, solvates only cationic part. And anionic part comparatively remains free, and anionic part remains comparatively free. Now you must be thinking in your brain that why anionic part remains comparatively free. I will give you the answer, but you have to wait for a second. Now just see. If I write down dimethyl sulfoxide, see everyone, dimethyl sulfoxide, S double bond O, carbon H, carbon H. This is dimethyl sulfoxide. The sulfur is having partial positive charge and oxygen is having partial negative charge. Is it okay? Hey, have you got bored or but full of energy? Kids, now suppose if NaF has approached Na positive, F negative, and NaI has approached, kids, this oxygen will say, hey Na, I love you. This oxygen will say, hey Na, I love you. Sulfur is saying, hey fluoride, I'm having positive charge, you are having negative charge. I'm having positive charge, you are having negative charge. I love you. Fluoride will say, okay, even I love you, sulfur, but you are too much sterically hindered. You just see yourself. Sulfur, you are too much sterically hindered. Too much sterically hindered. We are unable to come to you. This part is too much sterically hindered, so we cannot approach you. So kids, polar aprotic solvent, they are not going to solvate the anionic part. So the anionic part size will not get changed. The size of anionic part will not get changed. Kids, everyone, are you able to understand? The size of anionic part will not get changed as they were in air, they were in molten state, they will remain like same. So who is larger? Iodide is being larger in size. You can see this is being larger in size, and this is being smaller. So who will run fast? The smaller will run fast, and that's why in polar aprotic solvent, this is the order. Everyone, are you able to understand, kids? Have you got the reason? Everyone is able to understand the reason or not? Kids, do let me know that yes, it's clear to each and everyone. Now, what is going to happen in NPS? See, NPS, non-polar solvent. NPS examples are CCl4, carbon disulfide, benzene, toluene, xylene, like this, etc. These neither solvate cationic part nor anionic part. These neither solvate cationic nor anionic part. It is just like that. I'm not going to do anything. You just do it yourself. Now see, we are having NaF. It's like this. We are having NaCl like this. We are having NaBr like this. And we are having NaI like this. What is this, kids? What is this? These are the bond dissociation energies. Who's having maximum bond dissociation energy? Bond dissociation energy. Have you heard the name bond dissociation energy? So NAF is having maximum bond dissociation energy. Maximum bond dissociation energy. So can't break easily, and this is having least body, so will break easily, and once the one who is going to break easily is the best nucleophile. You got it. Now kids, this much is everyone able to understand. Now I am going to deal with question, the fantastic question. Do let me know, is everyone ready? Don't think that this lecture is going to be a very big lecture. Just I will take 20 minutes more, not more than that. Hardly 30 minutes more, kids. Hardly 30 minutes more, right? So see, everyone, just see to it. Let me tell you Williamson's synthesis of ether. Williamson's synthesis of ether, the number of questions. See, kids. First question. Williamson's synthesis of ether. Very, very important for all examination. Williamson's synthesis of ether. So very, very important for all exams. Let me tell you, it's very, very important. Very, very important for all the examinations. What Williamson said, he said, whenever you want to prepare ether, you take Rx plus R dash ONA, R dash ONA or K in presence of dry ether. In presence of dry ether. This X negative will combine with what? This Na positive, both of them, they will combine together to form what? ROR dash. R dash O R plus NaX. But remember that this Rx must be least sterically hindered. Must be least sterically hindered. What is that? Least sterically hindered. That is, it should be either 1 degree or 2 degree, but should never be, but can't be 3 degree. This already I have told you in mechanism kits. This already I have explained or not? Okay. Now see kids. If I say the question was asked like this, arrange the following. Really good question. Arrange the following in decreasing order of rate The questions are like this. A option, CH3, 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 Cl plus C2H5ONA. The second reaction is given like this. B reaction, CH3, CHBr, CH3, the same reagent. The third reaction is like this, CH3, CH2, I, and the same reagent. And the third reaction, fourth reaction is like this, CH3, I, the same nucleophile, each and everything is being same. Do let me know if you are able to solve this question. That means you can solve this question in your NEET also. I'm waiting for your answer, kids. Try to give me the correct answer. Let me check it out. What answer you are going to give, kids? I'm waiting for your answer. Yes, everyone, I'm waiting for your answer. Kids, do let me know. DCBA. D. So you made it easy kill question, kids. Absolutely correct. Absolutely correct. DCBA. Stupendous performance shown by you, kids. Really awesome. It's a great accomplishment because we know that this is 3-degree alkyl halide, can't show SN2, no SN2, no SN2. This is 2 degree, this is 1 degree, and this is least sterically 1 degree. Now, kids, the really two fantastic questions, fantabulous question. First question is easy, but second question is tough. First is easy, second is tough. First, let me give you the easy question. Question is, which will not produce ether? Which will not produce ether, right? Okay. Let's see whether you are able to do it or not. The A1 is CH3 whole thrice COK plus CH3Br. This is the reaction. The second one, B1, is CH3 whole twice CHONA plus C2H5Cl. The C1 is CH3 and CH2ONA plus CH3 whole thrice CBr. And the last one is C2H5I plus C2H5ONA. So let's see what answer you are going to give, whether your answer is going to be right or wrong, kids. I'm waiting for your answer, kids. This is the easy kill question, but I don't think that everyone is going to get the correct answer. Everyone won't be able to get the correct answer. A. Priyanka is writing A. Let me wait for others. Kids, this is game-changing question, looking to be easy, but you will get failed. Anaconda question, kids. Such type of questions, I will say anaconda question. What do you mean by anaconda question? Looks easy, but you are going to get negative marks. Anaconda questions looks easy, but people gets negative marks. Hey, everyone is writing A, but Let me tell you, Akanksha, your answer is correct. C is the correct answer. C is the correct answer, kids. Maximum students have gone for A, but C is the correct answer. Should I let you know what mistake is done by majority of the students? Kids, should I let you know or not? How many of your answers has gone wrong? Show me thumbs down. Those who have got the correct answer, thumbs up. Then I will let you know, kids. And hit the like buttons, kids. Smash the like buttons. What are you doing? You are not loving your HSP Baba. The way he's teaching, you're not loving that. How much hard work I am doing for you, kids. First of all, make it 90. The likes should go up to 90. I want to see more likes. This is not the way. Kids, the number one rank producer is standing in front of you. He's teaching you. And you're not good, not smashing the like buttons, kids. Let's see. Let's see. You know, these reactions are taking place in the flask. These reactions are taking place in the flask. That you know very well. Now, if I make flask like this, round bottom flask, what do you think? Which side the reactant is present? Right hand side, left hand side, or it's inside this flask? The reactant is present which side? The right hand side or the left hand side, or in the flask? It's moving in the flask. Kids, do let me know. The reactant is present which side? Right hand side, left hand side, bottom, or the number of molecules are there? They are present everywhere. 1 mole has 6.023 into 10 is for 23 molecules. They are present everywhere, or they are just located on the left hand side or right hand side. Kids, do let me know. Everyone, do let me know, kids. I want to see you answer. They are inside the flask. But whenever we are going to deal with paper question, 99.9% students, they are looking for reactant over here and reagent over there. No, that is absolutely wrong, kids. Reactant is the one who is providing its carbon during the reaction, whose carbon is involved in the bond formation. See, this is having carbon CX. So this is your reactant. Just try to find out which one is your reactant. Then only you will come to know this is your reactant. If you are able to find out which one is reactant, which one is reagent, then only you are going to understand what we are going to find out. This is the reactant. And this reactant is 1 degree. So it will show SN2 reaction. It will show SN2 reaction. Now in this reaction, this is ONA, RONA. This is your reagent. This is your reagent. Are you able to understand? This is your reagent, and this RX. This is your reactant, and this reactant is 1 degree. This will also give SN2 reaction. Agreed? Now here this is RONA and this is reactant. This is 3 degree. No SN2. It will not give SN2. And here this is reactant, and that is your reagent. Kids, you got it? What mistake has done by you? What mistake you... Yes, you have done the mistake. What mistake? You got it, everyone. Do let me know, kids. Is everyone able to understand? So now another question. See, I hope that everyone is able to understand this thing. It is clear to each and everyone's kids. Now, this is your question. Try to understand. Here is bromine. Here is chlorine, and it's written like this. This is a question already asked. Once it has been asked in IIT. C2H5ONA excess. What should be the product? Should I give you the options? You need options. I think that you need options, right, kids? Let me make options. Don't worry. 1, 1, 2, 1, 2, 1, 2. A OC2H5, that means ET. I can write OET. Second option B, OET chloride, like here. Now OET. C option. D, all of these. Here C, BR over here, all of these. Do let me know. You will go for which option? You will opt for which option, kids? Everyone, do let me know. This question has been asked in IIT. Already it has been asked, kids. Do let me know. Easy peasy lemon squeezy. Srinath is saying easy peasy lemon squeezy. Kids, Srinath, everyone, let me tell you, your Avengers batch, definitely the kids are going to get the best rank over there. Really, they are doing well. And today is the last day to enroll in your dream batch, that is Avengers batch. After this, you won't be able to enroll in that batch. D. Akanksha is going for D. Aarti is going for D. Kids, once again, I would like to say you got failed. Once again, you people got failed. The correct answer, before telling you the answer, let me show you something. Just try to understand. Whenever any atom is attached to double bonded carbon, that is sp2 hybridized carbon, that is vinylic atom, that is called as vinylic atom. And vinylic atoms are poor leaving group, means that they are not going to leave. Poor leaving groups. Why they are poor leaving groups? Because their lone pair participate in resonance. When their lone pair is participating in the resonance, the single bond will develop partial double bond character, kids. This single bond will develop partial double bond character. Single bond will develop partial double bond character. So it is not going to leave, and that's why I've told you, kids. That's why I've told you what you are is not important, where you are is important. Now you're not able to understand what I've written. I hope I will write it down on the next page. Don't worry, I will write there. Let's find out here that this bromine atom is poor leaving group. Vinylic atoms are poor leaving groups. Just a second. Vinylic atoms are poor leaving groups. No. Okay. So vinylic atoms are poor leaving groups. Why they are poor leaving groups? I will let you know, kids. I will show you. Okay. Now kids, this is adjacent to this sp2 hybridized carbon. This is known as allylic atom. This is known as allylic atom, and allylic atom are very good leaving groups. Very good leaving groups. Whether it is given in Axis, that was the trap of the examiner. Examiner was trying to trap you and you got trapped. So you have seen this given in Axis and you thought like, let's remove both. This will leave, this will not leave. Allylic atoms are very good leaving groups. Very good leaving groups. In Avengers batch, I told them a story. If you belong to Avengers batch, I've told you one story of captain of the ship, Titanic ship story. Captain of the ship, rat of the ship, normal leaving group. Kids, if you anyone from Avengers batch, you know that story, the best story I've told you. Now, what is the answer? This is not going to live and this is going to leave. You must have thought that this is good leaving group. No, it depends on the position. This is sp2 hybridized, not going to leave, and this is sp3 hybridized adjacent to this allylic atoms, good leaving group. This is going to leave, this is not going to leave. What is the answer? C is the correct answer, kids. You got failed or not? So concepts are really very, very important. Now I'm going to take just 15 minutes more. After 15 minutes, that this is going to get completed, kids, each and everything. Now see, really awesome question. This question holds a hell lot of weightage. Just try to understand it. Question, what is the product? Find out the product. Find out product. Now the question is, kids, really very, very awesome question. The question is given like this. Here it's given bromine, CH3 and C2H5. You have just to let me know your product will have ring of how many members? C2H5ONA. The product will be having how many carbon ring? The question is having 5-membered ring. Here is 5-membered ring. 5-membered ring. 5-membered ring. The product will have ring of how many carbon? The product will have ring of how many carbons? How many carbons? Do let me know how many carbons. Everyone do let me know, kids. I'm waiting for your answer. I'm waiting for your answer. Do let me know. The ring will have how many carbon atoms? Quick, 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 everyone. Okay, let me, right now SN2 reaction will not take place. Let me make it hydrogen. Let me make it hydrogen, otherwise reaction will not take place. Let me put hydrogen over here, right? Now, SN2 reaction will take place. This is hydrogen and 2-degree alkyl halide. This is just 2-degree alkyl halide. So now you tell me the answer. What should be your answer? I'm waiting. Now, 5. Oh, great. It's really awesome work. How you managed to give this answer. Absolutely correct. Absolutely correct. 5-membered ring, and this will attack from the back side. Backside attack. Really good. How you have given the answer. Unbelievable. Really stupendous performance, because it is SN2 reaction. SN2 reaction, and this is being a strong nucleophile. So reaction will take place in single step. inversion of configuration will take place. No rearrangement because SN2 reaction takes place in single step. So here this will go that side and you will get OC2H5. Product will be of 5-membered ring, no ring expansion. In SN2 reaction, no ring expansion. That's really fantastic. Now kids, last two factors are left. I've told you about R, I've told you about X. Now I've told you about nucleophilicity also. Now two things are left, the role of temperature and the role of solvent. High temperature is good for this reaction or low temperature is good for this reaction. Factor number 4, role of temperature kids. Role of temperature. Role of temperature. Do let me know high temperature or low temperature. So let me tell you, low temperature is good. Low temperature is good for SN2 reaction. Is good for SN2 reaction. Now you will ask, why sir? Why low temperature is favorable for SN2 reaction? Sir, just tell us the reason. What's the reason? So kids, reason lies in thermodynamics. Reason lies in thermodynamics. Reason is from thermodynamics kids. Thermodynamics. Just think how thermodynamics is going to help. And this is missing part in NCERT. Missing part in NCERT. So I am going to tell you kids, this is missing part in NCERT. An examiner will definitely ask you question. Now let me tell you kids how. Just try to find out. If I say this is the reaction which is going to happen, CH3 Br plus C2H5ONA. Let's think like this is 1 million molecules. 1 million molecules, right? We cannot count the molecules. 1 million molecules. We know that 1 mole has 6.023 into 10 to the power 23 molecules. I'm just taking 1 million. Let us suppose 1 million. These are also 1 million. Now the reaction is going to take place. This Br will go along with Na and you will get product. You will get product kids. What should be the product? Definitely the product is CH3 O C2H5. Inversion of configuration has taken place and NaBr. So just try to find out one type of molecule, another type of molecules. There are total 2 types of molecules, or you can say 2 million molecules. 2 type of molecules. 2 types of molecules or 2 million molecules. Whatever you want to think, you can consider. Now when these 2 types of molecules got destroyed or 2 million molecules got destroyed, how many types of molecules got produced and how many molecules got produced? 2 types only or 2 million only? So whatever is getting destroyed, the same type, not I will say type in sense of product, same number of molecules are getting formed. And this is the slogan of our world. V2 R2. 2 are getting died, 2 are new formed. Now see, if I talk with respect to change in entropy, entropy of final minus entropy of initial, I will get near about 0. I will not say exactly 0 because there are translatory motion, rotational motion, number of motions are there, degree of freedom are there. But approximately, I would like to say it is 0. It is 0 approximately. If I say enthalpy, change in enthalpy. So see, big bond is getting broken up. Big bond. Why big bond? Why big bond? This is 2p. This is 4p. weak bond is breaking up and stronger bond, this is 2p and this is 2p, stronger bond is getting formed. So energy required is less energy is required to break this bond, less energy is required and more energy is released, so overall this reaction is going to be exothermic reaction. This reaction is going to be exothermic reaction. Now kids, if I apply Gibbs-Helmholtz equation, delta G is equal to delta H minus T delta S, what will you say? This is 0 and this is exothermic reaction, and for exothermic reaction low temperature is favorable or high temperature is favorable, and all organic reactions are reversible. So Le-Chatelier principle, you can apply Le-Chatelier's principle. If you're not able to apply Gibbs-Helmholtz equation, you can simply apply Le-Chatelier's principle. So Le-Chatelier principle says it's better to have low temperature for exothermic reactions. Low temperature is favorable, right kids? Low temperature is good. Everyone kids, do let me know that this fundamental thing is clear to all of you or not, because just 7 minutes more, then I will complete each and everything. Is the rule of temperature clear to each and everyone or not? So whenever we are going to deal with nucleophilic substitution reaction, low temperature is good. Now, last but not the least, whether PPS is good or PAS is good, see the question, last one. If I say this question, this is a reaction, CH3 CH2 I plus CH3 ONA and it's written over here water. Water has been given over there. The second reaction, CH3 CH2 I plus CH3 ONA, and here DMSO is given as the solvent. We know that water is polar protic solvent and DMSO is polar aprotic solvent. Kids, the question was which will react fast? Compare the rate of reaction. This was the question, kids. Compare the rate of reaction. So, is there anyone who can give the answer? Is there anyone? Let me tell you the answer. Everyone, let me tell you the answer. The reactant is same. In both the reaction, reactant is same. This is the reactant are same. The nucleophile is also being same. Only the change is of solvent. Here it's the solvent PPS. Here is the solvent polar aprotic. Now kids, we know that SN2 reaction is a fast reaction. When the nucleophile is going to attack on this carbon from the back side, this is the nucleophile which is going to attack. This is the nucleophile CH3O negative. This wants to attack on the ABMO fast. If water is there, water, you know that polar protic solvent, water will come and surround it from all these sides. Water will surround, or I say polar protic solvent will surround it from all the sides like this HOH. This H plus will form a bond with this HOH. H plus will form a bond like this, and it won't be able to attack fast. it will get captured, will get trapped. So speed will decrease because nucleophile got trapped. It got trapped. But if we are having DMSO, you know that DMSO, polar aprotic solvent, never touches the anionic part. PAS, do not solvate, don't solvate anionic part. So if CH3O negative is going to move, it is free in PS, it's free to move, it's totally free, or you can say it's free to move. Now kids, if you are able to understand, in PPS it's like this is in PPS, it got captured, in PS it is free. Which CH3O negative methoxide is going to move fast? This is going to move fast, so this is fast reaction and that is being slow reaction. Everyone able to understand? Both are being SN2. This is also SN2 reaction, that is also being SN2 reaction. The yield will be ether only, but in one we are getting fastly the product, in another one we will get product in slow mode. It's time is up, all the type of reactions are up. After this I will take care of SN1 reaction, then combine together SN2 and SN1. I will tell you the applications of NCERT, and I will put one video in which, or in coming video, what I am going to tell you, the magic, I will show the magic. That magic already I have shown in Avengers batch. If you are going to be the part of Avengers batch, then you can see that magic. Otherwise, I will show you one magic. That magic means how to find out whether it is SN2, E2, SN1, E1, just within 10 minutes without teaching. I will tell you a story of doctor and patient. I will not teach for 10 minutes, but you people will be able to understand whether the reaction is SN2, E2, SN1, E1, parallel SN2, E2 altogether, SN1, E1 altogether, only E2 reaction like this. Kids, you must be thinking, sir, what you're talking about? This is not possible. Yes, this is possible. If anyone belongs to Avengers batch, that student definitely knows better that yes, this is possible. Shiva Kumar, yes, I will let you know. Kids, bye to all of you. All the best. Now, I have got one session. That session is Ask Me Anything. Me and Venugopal sir on our IITJEE channel. So, I have to go over there. Just one session of Ask Me Anything. So, we are going to start that fantabulous session at 9 sharp. Bye to all of you. We'll meet you. Jai Hind, Vande Mataram. All the best. All the best. And kids, remember one thing. Don't miss even a single lecture. If you really want your success, then remember there is no substitute of hard work. Those who are really doing hard work, their success is waiting. So, never forget to do hard work, kids, and never forget to sleep, and never forget to study with the best teacher. There are a number of YouTube channels. You can compare this channel with other channels. Then you will come to know, yes, this channel means a lot. It holds a hell of a lot of weightage in your, it's going to be definitely, it is going to give you the best success, the best rank, kids. Bye. Finally, we'll meet you in next session.